Today we are going to study about ionic conductance. So, first of all, what is the electrical conductance? In ionic or electrolytic conduction, ions are responsible for the electric current, as well as in metallic conduction, electrons are responsible for carrying the current. Positively charged ions, that is cations, moves towards the negative electrode or cathode. This is called reduction. And the negatively charged ions move towards the positive electrode, that is anode. This is called oxidation. Now we come to electrolyte and electrolysis. Electrolytes are electrovalent substance that forms ions. Those substances which forms ions, that is cation and anion in the solution, are known as electrolytes, and they conduct the electric current. Cations are the positively charged ion which moves towards the cathode. Cation means ion moving towards the cathode, and anions are negatively charged ions which moves towards the anode. Cation is ion moving towards the cathode, and anions are the ions moving towards the anode. The phenomenon of decomposition of an electrolyte by passing an electric current through the solution is known as electrolysis. That is, electrolysis is a phenomenon of decomposition of electrolyte by passing electric current. Example, electrolysis of HCl. It furnishes H positive and Cl negative ion. L here is small. Electrolysis of sodium chloride, NaCl. Now, this is the electrolytic cell. One positive electrode and one negative electrode. That is, one electrode is connected to the positive terminal of the battery and other is to the negative terminal of the battery. And it is filled with ions. It is filled with electrolyte which furnish positive and negative ions. These ions migrate towards the respective electrodes, and this is known as migration of ions. The migration of ions can be experimentally studied by a simple experiment. The migration of ions with different speeds can be demonstrated by a simple experiment devised by Noyce, is the name of scientist. We take the U tube and is filled with 3/4 with dilute solution of agar-agar containing KCl and a little phenolphthalein. The U tube is filled with 3/4 of the dilute solution of agar-agar containing KCl and a little phenolphthalein. Now, a drop of dilute solution of NaOH is added into right limb, and a drop of HCl is added in the left limb. So what happened? As a result, the solution of agar-agar is colored in right limb, pink color, and remain colorless in the left limb. Why? Because phenolphthalein gives pink color with NaOH. That is in basic medium. and in acidic medium it remains colorless. So, as a result, the solution of agar-agar is colored pink in the right limb and remains colorless in the left limb. Now, the agar-agar solution is then allowed to set into a jelly by placing U tube in an ice bath for a few minutes. The U tube is placed on the ice bath for few minutes. So, the agar-agar solution is then allowed to set into a jelly. Then, a small amount of powdered charcoal is scattered on the surface of the solution on each side to mark the position of the boundary. When we add the charcoal solution, it clear-cut marks the position of the boundary. See, this NaOH and HCl, and this is the charcoal. Now, a solution of HCl and cuprous chloride is gently poured over the charcoal boundary on the right side, and NaOH is poured over the charcoal boundary on the left side. What we have done, once the charcoal boundary is set in the right side, we pour the solution of HCl and cuprous chloride, and in the left side we pour a solution of NaOH like this. See in the figure. Now, two electrodes are dipped in the limbs of U tube, and current is allowed to flow by immersing metal electrodes in each limb. The anode on the right and cathode on the left. The right hand side is anode and the left limb is cathode. As a result, the hydrogen and cupric ion, Cu plus 2. Yeah, what we add here? Here we add HCl plus cuprous chloride. Cupric chloride. So, what happens? Copper plus 2 ion and H plus ion moves towards left limb, that is towards the cathode, and OH NaOH डाला तो hydroxyl ion moves towards the anode, that is right limb. The movement of hydrogen ion is indicated by the disappearance of the pink color. And that of cupric ion by the development of blue color in the solution of the right side. What happens? Hydrogen ion ka movement is observed by the disappearance of pink color, because as the hydrogen ion approaches, the medium becomes neutral and pink color disappears. And that of copper ions by the development of blue color in the solution of right hand side. The movement of hydroxyl ion is indicated by the appearance of pink colored solution in the left. As the hydroxyl ion moves towards the anode, pink color is developed on the left side. So, this experiment shows that the ions moves towards the respective electrode. Experimental result shows that in the given time, the hydrogen ion moves through a distance of 5 cm and copper ion moves through a distance of 0.91 cm and OH ion moves through the distance of 2.83 cm. That is, the different ion move with different speeds. So, this experiment shows the migration of ion towards the respective electrode with different speeds. Now, to demonstrate this and to show the discharge of ions of electrolyte, Hittorf proposed a theoretical device which is known as Hittorf's theoretical device. See, this is the figure of Hittorf theoretical device. This device shows that although most of the ions differ largely in their mobility, their equal numbers are discharged on electrolysis at appropriate electrodes, respective electrodes. Second, the anomaly is explained by Hittorf theoretical device containing equal number of positive and negative ions of same valency. Two metal electrodes A and B represent anode and cathode. The vessel is divided, into 3 compartments by putting imaginary partitions C and D, which are permeable to ions. The compartment C and D are permeable to ions. The 3 imaginary compartments AC, CD and DB are termed as anodic compartment, central compartment and cathodic compartment. Before electrolysis, the position of the solution is represented as at 1 in the figure. On applying potential, suppose only 2 ions, 2 cations are capable of moving, and in the given time 2 of the cations moves towards the cathode. Cation कहाँ किधर मूव करेंगे? Towards the cathode. The condition is represented in the figure as 2. Second, there will be 2 unpaired cations in the cathodic compartment. There will also be 2 unpaired anions left in the anodic compartment. As unpaired ions always gets discharged at the respective electrode, either by loss of electron or by gain of the electron. So, 2 cations will be discharged at cathode by taking an electron, and 2 anions will be discharged at anode by giving their electrons, even though only cations are able to move. In this case, we see that the concentration of middle chamber, central chamber remains constant. It remains constant. Now, in second case, represented as third in the figure. In this case, both cations and anions move, and both have the same speed. That is, if 2 cations move towards cathode, 2 anions will move towards the anode at the same time. See, figure 3rd. So what happened? Now here 4 cations and 4 anions will be discharged at their respective electrodes. Therefore, one another case represented by 4th condition. In this case, cations and anions move with different speeds, so that if in a given time 2 cation moves towards the cathode, 3 anion moves towards the anode. So you can see 2 cations move towards the cathode and 3 anions, negative ions, moves towards the anode. Again, number of unpaired ions is 5 in both the chambers. 5 unpaired cations and 5 unpaired anions will be discharged at their respective electrode. In all the cases, the concentration of central compartment remains constant, and this can be realized in practice when the current strength is small and there are no temperature variations. So, this is about the Hittorf theoretical model. Next, we study transport number in the next lecture. Thank you.